The diagram below shows an electric motor lifting a 200 kg object at constant speed of 3 meters per second. Then define the term power in words. Power 8.2.1. Power is the rate at which work is done. The rate at which work is done. That will be 2 marks for that, if you got that one right. Calculate the magnitude of the force exerted by the cable in order to lift an object of 200 kg at constant speed. And if we draw a small free-body diagram there for the object, we have the force applied by the cable upwards, as well as the gravitational force, so the weight of the object there. There are only two forces that are acting. There are only two forces acting, and we were told that it moves at constant speed. Constant speed, constant velocity means that the forces are balanced. That's because for us to have constant speed, it means there's no acceleration. For us to not have an acceleration, it means that the net force is zero. There is no resultant force. So there's no force between the two that is bigger than the other one. So they are equal there and opposite as well. But what is important for now is that they are equal. That means that the applied force that is doing the work is equal to the gravitational force. And therefore, when they say calculate the work, the force on the cable is equal to the weight of the object. The weight is equal to mg. So we have here 200 multiplied by 9.8, giving us a 1960 newtons of force there. So for that, 1, 2, 3, the force that is being applied is equal to the weight. So we calculate the weight when they say calculate the force applied by the cable there. Calculate the work done by the electric motor to lift the object. The work done is equal to the force of the cable multiplied by the displacement multiplied by cos theta. Remember, the force is equal to the weight, 1960 multiplied by a displacement of 3 multiplied by a cos of. Now the question is, what is the angle between the displacement and the force applied there? Now, in order to know displacement, what is displacement? Displacement is simply the direction of motion. Where is the object moving? The object is being lifted, so it's going upwards. So you see the displacement and the applied force are in the same direction. That means that the angle between them is 0 then. If you have an object that is going up, that is being lifted up, and it goes up, so it means that the force and the displacement are in the same direction, and the angle between them is 0 there. So we get here 588 joules there of work done there. And then 8.2.4 here, calculate the power needed by the electric motor there. It's allocated over there. 1 mark for the formula, substitution, as well as the answer there. Calculate the power in watts there. So what do we have? We do have the work, but we don't have the time for formula power, work over time. But we do have the force there and the speed there. We're given a speed of 3 meters per second over there. That's it over there. So we have the formula, average power is equal to average force multiplied by the speed there. So we have the force being applied by the cable is 1960 and a speed of 3 meters per second. So this is going to give us 5880 watts of power there. And for that, it's 1, 2, and 3 there. And then now convert that power to horsepower. So we have that 5880, we divide this by 746. That power divided by 746 it gives us a, so we have 5880 divided by 746, giving us a 7.88 horsepower there. All right, and there will be 2 marks for that there. And we have an activity here out of 14 there, 14.